All right, hey students, so this is the second part of our dilations examples, which is basically more on scaling backwards, meaning we're going to scale things down. So instead of enlarging, we're shrinking. Sorry about that, students, if you saw the random pause there. That was somebody at the door. I had to go let them in. Okay, so let's talk about scaling images down instead of up. And I'm going to give you guys a quick example. So or at least one example here involving a square in the second quadrant. I'm going to place point A at the origin. I'm going to place B, 5 off of that, 1, 2, 3, 4, 5. C is then going to be 1, 2, 3, 4, 5 out. And then D is down here. Okay, so what you're left with is a typical pre-image square. And we are going to shrink him down by a specific scale factor. Okay? Now you're probably wondering, what is that scale factor going to be? Again, of course, you need to make sure you're at your pre-image information. Okay, A, B, C, and D. A being, of course, 0, 0. B being 0, 5. C being negative 5, 5. And D being negative 5, 0, right? And of course, our image is going to be A prime is 0, 0. B prime is 0, 2.5. C prime is negative 2.5 and 2.5. And D prime is going to be negative 2.50. Now, the astute of you will probably have noticed that this scaled down by half. How do I know this? Because half of 5 is 2.5. So our rule would be scale factor of 1/2, and the formal algebraic form of that would be 1/2 x, 1/2 y. And there you go. So let's graph the now image, right? Let's see. So we're going to go up 2, a little halfway right there. A doesn't move. Over 2, little halfway. And then from there we can go 1, 2, and then it's right in the middle of that coordinate value. Okay, and then of course we connect up the lines. And this is just something I picked up from another teacher recently, but she recommended shading in the region after we do it. So that way we can see the comparison. Looks pretty good. All right. And of course, this is also doubling as A prime. This is B prime, C prime, and D prime. And you can see how the slope from each individual point location is relatively consistent, and that as the shape shrinks, it's getting smaller. You'll also notice that it's not shrinking internally, it's shrinking to the origin. That's kind of important because when you think about this, we think conceptually, okay, when I dilate something, we think of our eyes, they're dilating and they're not doing that. If that was the case, our pupils would literally move to the right side of the iris, the left side of the iris. Well, it doesn't do that because they're centered. And we're going to talk about a center one. We're going to do that one last down here, number 6, where you can see a little Y here. Yeah, that's where number 6 is. We'll do him last. But right now, we're going to jump into number 5. So number 5, actually here, I'll keep that up there so that way if you're still writing, you can keep up. So for number 5, let's talk about number 5. All right. So number 5, we have a pre-image of a pentagon. All right, and it's at 3, 5. So 1, 2, 3, 1, 2, 3, 4, 5. I think, right? Let me double check. 1, 2, 3, up 5. 1, 2, 3, 4, 5. Yep, right there. Okay, so there's A. B is at 5, 3. 1, 2, 3, 4, 5, up 3. Okay, C is over 4. 1, 2, 3, 4, up 1. D is over 2, up 1. And E is over 1, up 3. 1, 2, 3. Okay. And we connect the lines. Okay. There we go. And so we have A, B, C, D, and E, right? A, B, C, D, and E. And so our pre-image is as follows from those points. All right, I've got some pens in my way. I need like a pen cup, like up this way, but I don't have one. All right, pre-image. So our pre-image for A, B, C, D, and E. A is going to be, again, 3, 5. B is going to be 5, 3. C is going to be 4, 1. D is going to be 2, 1. That's just the AC unit for those of you who are curious. I don't know if you can hear it. I can. It's loud. E is 1, 3. And instead, I'm not going to give you guys the image yet. I'm going to give you the rule instead. Our rule is scale factor of, again, 1/2. Big surprise. And again, the algebraic write-up for that is xy becomes 1/2 x, 1/2 y. Right? Now, you're probably thinking to yourself, hold on a second, there's some odd numbers in there. Yes, this is going to be a relatively unpleasant looking situation, or at least problem, I should say. Don't freak out. So, okay, first of all, the image, because it's easy to calculate this stuff. What you have to remember is that 3 5, right, is how you take and deal with fractions. Okay, so I'm just going to bring a sticky note over here real quick. So I don't mean to cover this up. I don't really know where to put it. So we're going to bring a sticky note in, and we're going to do a recall. All right, so recall, when you're dealing with fractions, remember that 1/2 is the same thing as 0.5, right? It is half of an amount. So if I got a circle, it's half of it, right? Which is also known as 50%. Again, you can then take this and convert it to a decimal, which then can be converted to a fraction, okay? And you can see how the trend works, right? Now, why is that such an important little tidbit of information? That's an important tidbit of information because when you're technically taking a number and you're dividing it, for example, you have 1/2 here being multiplied by 3/5. So let's just take a look at that for a second and write it out, okay? We've got 3, 5, and we're going to try and apply that to 1/2 times 3 and 1/2 times 5, which then becomes, all right, so we then take these guys, multiply them together, and we get 3 halves and we get 5 halves. Now, the thing is, you can still simplify these down because technically this is the same thing as 1.5 and, of course, 2.5, right? And the reason for that has to do with the fact that half of 3 is 1.5 or 1.5, and half of 5 is 2.5, right? So you mentally have to kind of picture that, but you can see how we're getting to this point, and therefore that is our first point for our image, which is A prime is going to be 1.5 and 2.5. Now you apply that logic to all the other ones. So B prime will be 2.5 and 1.5. C prime will be 2 and 0.5. D prime will be 1 and 0.5. And E prime will be 0.5 and 1.5, right? So then, okay, move the one out of the way for now. I'll put it back in later. But now we're going to graph this guy. So we graph him real fast. Okay, so A prime is going to be over 1.5 and then up 2.5. So he's right there. B prime is over 2.5, up 1.5. So there's A prime, B prime. C is over 2 and then up 1/2, which means it's right on top of D there. Okay. D is over 1, up 1/2. There's D prime. E is then over 1/2, up 1.5. And there's our little baby pentagon. Okay. So yes, they can get pretty annoying depending upon how we graph them out and what the size is and all that stuff. But at the end of the day, that is the proper scale, right? And that would be E prime over here. There we go. And there it is. All right. So we got one more to talk about. I'm going to put the sticky note back in because I like this as a little recall here. It's very nice, very helpful. Okay. And I recommend doing that. I recommend putting sticky notes in your notes saying, hey, you remember doing this in school? And then, you have a good reference. Now let's do something where if it's on center, so as you notice, when we shrink these down, they're not in the center of their original shape. They're shrinking down to the origin point because this is the focal point. But what if the shape was on the origin point, meaning it was centered on? So this next big one here, we're going to talk about that. It's going to be nice and big. So we're going to talk about a scale factor, and we're going to take this look at a square here that I'm going to make as a diamond. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here's a big old diamond, right? If you like baseball, it kind of looks like a baseball diamond. You can see there's first, there is third to second, second to first, first to home. For everyone watching that likes baseball, I completely botched the order in that. I'm sorry. And then, of course, home to third. Unless you're throwing the ball from third to home, to get somebody out. It kind of works. All right. I will do it this order, though. A, B, C, and D. Okay? So, our pre-image, right? Our pre-image, and we have our image. Okay. Now our image, of course, is A, B, C, and D, where A is going to be 8, 0, B is 0, 8, C is -8, 0. That is a -8 there. I apologize. And D is 0, -8. Okay. Our rule would be a scale factor of 1/2, which means xy again becomes 1/2 x, 1/2 y, right? So that means all of those values are going to get cut in half. So for example, we break this down. A prime should be then 4, 0. B prime should be 0, 4. C prime should be -4, 0. And D prime should be 0, -4, right? Okay, so if we graph this guy up, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. And there, of course, is now our image. Now you can see that since the center point is at 0, 0, and since the shape is centered on 0, 0, the scale, or the scaling factor that scales it down, is, or appears to be, I should say, symmetrical. Okay? And what I mean by that is that basically, if I fold this guy in half, it works. If I fold any of these guys in half, it doesn't work. This is why dilations are so weird and why they're also not rigid. Okay? Because it has to be based on its placement for it to be quote-unquote technically symmetrical with itself. And in this case, it technically is in terms of the fact that you fold in half, it's symmetrical. But keep in mind, it is a shrunken down versus the shape. So the image and pre-image is symmetrical, but they're not symmetrical to themselves. I want to correct myself there. Okay? But their resultants and their pre are symmetrical. Okay? So, of course, let me just label these up. A prime, B prime, C prime, and D prime. All right. So hopefully, if you have any questions, don't forget to ask me if you have me in if you're in one of my classes. Otherwise, good luck, and I wish you guys best of luck on your homework and your individual assignments.